Is Michał. I work at Reality Games, and today I want to show you a whole developer workflow with a nice experience. So we want to put something on production with higher level of certainty than usually. And I will be using two pretty different concepts of functional programming and service meshes. So I want to use concrete example to introduce those two things and show you that by using those tools, we can have a much more certainty about what we are doing when we are deploying to production. So in this talk, the talk is divided basically into two parts. The first one is code, and the second one is deploying this code to production without disrupting existing functionalities. And in code section, we'll be using functional programming functions as first-class citizens, and Scala as an example to show you how can we approach testability in imperative world. So how can we test HTTP services, which are just JSON in, JSON out, with a state. So two separate concerns. How can we test them separately to have this high level of certainty? And then we'll be deploying this service, a production-grade service to production. We'll take care of accidental complexity like metrics, observability, tracing, things like that automatically. So this will be a service created from scratch, but which is not live coding talk kind of great, but production great. And this talk is about functions and meshes. So we'll be introducing, as I said before, functional programming like functions and service meshes. And I want to know what kind of audience do I have today. So who has some experience with functional programming? I mean, basics. Okay, majority of us. And what about service meshes then? Cool. So this means that we'll focus more on our service meshes. But please bear with me in the beginning when we're creating this service and pay attention to what kind of services, what kind of tests would you apply, what kind of assumptions about the service will you take. And in the end, after those two parts, we'll have some conclusion about how we approach testability of our current modules in the microservice architectures. So we'll revisit this unit integration end-to-end categorization and maybe come up with something different, more practical in the current world. And the concrete example is a very, very bad game, very, very bad Pac-Man game, which looks like that. So this is our current production. We can move Pac-Man around and not hit walls. So this is the current functionality. I wanted to have some kind of very, very simple example. So this is the production functionality that we want to have, even when we are introducing a new one. So the functionality is the front end is just a very, very dumb layer on top of the back end. Every 100 milliseconds, it gets something from the server and fetch and renders it. So fetch and render, nothing more. And the backend is responsible for whole of the game logic. So, for example, changing the direction, moving Pac-Man around, and keeping up with multiple games. So this is our current production. What we want to do is create from scratch a new service, which is called collectible service. This is the service that will keep up with all those dots that Pac-Man needs to eat. So we need to introduce this to production, to Kubernetes cluster, without disrupting any current functionality. So this is what we will be focusing on. So let's start. So majority of you is familiar with functional programming, but how about Scala then? Okay, fewer than before. So I'll be using HTTP, so more imperative world, and I'll be using very, very basic functional programming to separate some concerns, just to show you what's possible. Of course, there are many more. So we'll be starting with a TDD approach. So we'll be creating a test for our new collectible service. Collectible service will have three functionalities. First one is creating a new collection of positions. So this will be at the start of the game. The backend will send this kind of request to set up a new set of positions that can be eaten by the Pac-Man. So what we can do here, and we want to test only the HTTP layer for now. That's just to play around to see what happens. So we'll be testing this route, create collectibles route, and in HTTP we can just have put and say collectibles 1. So we'll be creating the first collectibles, which this HTTP sorry about that, entity. Entity, this will be application JSON, HTTP entity, this will be imported, and what I want to do here, sorry about that, IntelliJ, again, we'll have HTTP entity and application JSON, and we'll be passing the real JSON here, right? So we want to create a set of positions, and by set, when we are using the set in JSON, we need to have those brackets, and then let's create some positions. So X will be 1, Y will be 2 in the first position. So it must be real JSON. This is the first object, and the second object is X 3 and Y 4. So this is the JSON that will come in, and when we need to just pass it through our route. So no starting of HTTP server, just testing this thin layer, and then check what should be returned. So what should be returned here is we need to have JSON from the string. So let's parse what this route has returned, and this should be let's say 1, right? So 1 means that if this has accepted our request, then it will return the identifier, let's say something like that. So now this test should fail, like that, right? So it failed, and now let's create this functionality. I will just create the first one because most of you are kind of familiar with this approach. So just to show you how to separate two concerns from each other. So we'll be using path from HTTP collectibles, and then int number. Int number means that in this path we'll have this kind of integer, and it will be called collectible ID or collectibles ID. Okay, and then we want this request to be a kind of put request, and then we have this entity, which should be a set of positions, right? This is what we expect. So we want to get this set of positions, and then save it in the state and return an identifier. So this is positions, incoming positions, and we can just complete this with 1. So what are we missing here? So this is a route which does nothing, right? It just accepts this set of routes, and we can see that this is unused. So we need to somehow save it in the state. And the traditional approach is to have the state in this route. But in functional programming, we can just use functions as first-class citizens, and we can use functions to create assumptions or externalize our assumptions about what kind of functionality is needed in order to create this route, this HTTP route. And we can just say, let's create collectibles. We don't care about how to do that. We just say create collectibles positions. And of course, in order to do that, we need a function, right? So create collectibles should be a function from int, 2-parameter function int and set of position. And the return type, we don't really care about return type. We just care about this side effect, right? So we say unit. This is a basic approach, right? So we say unit. So a function will save something in the state. We don't care because this is just one concern, HTTP. We don't care about what kind of state we are using. We just say that we need state. Of course, our test now needs this create collectibles function. And in the test, we can just say that we don't really care, and just return something that doesn't do anything. And we can just run this test and see we have now we don't have JSON value, and now we see that this test is passing. So this is the kind of approach we are using. And in the second test, I won't be coding, just we will show you how it works. We can have a very, very similar approach. We can get remaining collectible positions, right? So this is a second route. It will be implemented like that. So collectibles int number with collectibles ID, get, right? So this will be a get request, and then again the same kind of approach. So we are using get remaining, which is some side effectful thing, and by passing the integer identifier, it returns a set of positions, and then we are completing with that. But this HTTP request, JSON in, JSON out, we don't really care about anything more. So again, this checks our assumptions by using real JSON. So it is also a documentation, right? Because those are the JSONs that we are using. And the third functionality of our very, very small microservice is something like that. So we'll be creating a collectibles route. So we'll be creating a request which removes one collectible or collects the collectible, right? So we need an entity. This is a position, X and Y. And we are putting something to this collect endpoint. Going through the route, again, very, very similar approach, going through the route and checking that the JSON that is generated, again, returns this identifier. So very, very similar approach. Again, as you can see, we have two functions because we need to externalize our two assumptions about what happens. So again, a path is collectibles int number at the identifier and collect. We have this put request and entity as position because we are collecting this concrete position. And then we just get remaining. We don't know where from. And then update this remaining. Again, a side effectful function in set position to unit. And then complete. So very, very similar approach. And now we can we have this functionality tested. So very, very thin HTTP layer, and those tests are very, very fast. So very, very, very fast. And one of them is rejected. Let's see why. So I probably misspelled something. This JSON has not been accepted because I removed this double quotes. And now those tests are passing. So we have this HTTP layer, but this is stateful HTTP service, right? So and we need to implement those functions somehow. And those functions will be implemented in the stateful HTTP route. So we need some kind of state, and we need to have this route, which is combination of those three paths, okay? So this is combination. So create collectibles route, and it says, because we want to create those three routes and in order to create the composite route, and it says by having this kind of function signature, what kind of functionality it needs. It needs to be able to create collectibles in this kind of state. So now we are connecting those dots, and we can think about what kind of functionality do we really want. So we can use something like try-map. And this is in Scala concurrent collection package from int to set of positions. So this will be our state. Again, HTTP layer doesn't know anything about this. And try-map, when you look at that, it's concurrent thread, safe, lock-free, and all of those buzzwords. So we should be okay by using that. So what then we need to put here? We need to just put this function, right? And that's all. So this is all we really need in order to create this composite functionality. And those 3 lines of code, again, just passing functions around, this is the whole service. We don't need anything more, except of certainty that the state really works together with the HTTP layer. And to do that, we will create another service using the very, very same approach. And it will fit on this one screen. The whole happy path with the HTTP JSON in, JSON out, with encoding, decoding, and state management. So we have this route. Given this route, this newly created one, so the composite one, when a new collectibles is added, again, very similar, the same approach. We are just passing something through route, right? The same technique, positions entity. This is the 2 positions that we want to store in the state. So we are putting that, and then one of the position is collected. So now we are checking how this HTTP API works with the state. Again, the same approach. Collect entity is an entity one position should be collected. So if we have in the state for this number 1, right, the collectibles with identifier 1, we have 2 positions, 1, 2, and 3, 4. Then if we collect 1, 2, what should we get here in response? So if we do get collectibles 1 and pass it through the same route, which is stateful right now, what should we get in return? Who's tell me? What kind of response will we get? Again, collectible service, we save. Okay, sorry? Yeah, so we should get 3 and 4. So the response, if we get collectibles, collectibles again, response as set of position. So we are decoding that again should be set of, you said, position 3, 4. And this is the whole test. At the same technique, we are not starting any HTTP server, but we have tested everything that we have coded. So the library authors that created this server should be responsible for testing the real server implementation, right? We are only concerned about our implementation of our endpoints. So if this one passes, then we are set, everything, and we can go to production, because this is how it works. So let's go that. Our server is tested and works fine. We won't be changing any more code because we have seen that it works fine for this happy path. So let's do SBT assembly. So we are creating a fat jar. And while this fat jar is created and Docker image built, I will show you how the current production works. So Kubernetes, who works with Kubernetes? And who is just familiar with Kubernetes, or how it works? Okay. So Kubernetes is a declarative approach to DevOps, to orchestration of the containers. So it usually basically just does that, container management and few more things. But we will be concerned just about the orchestration kind of thing. So Kubernetes is this user interface on top of the kubectl, which is the native command line interface. And you can see that we have 2 deployments. Deployment in Kubernetes is something that takes care of a container. So if the container goes down, the deployment, and we specified in deployment that there should be a container running for this particular image, it will automatically restart this so it's up. And we can set in deployment how many replicas do we want to have. So as you can see, we have deployment of backend and frontend, and those are ready and running with version 1. So this is our cluster. And let's see how this Pac-Man implementation works right now. As you can see, we are using this production cluster, which is a Minikube for now, but I also implemented that on real cluster, Pac-Man prod, and many requests. So this is not very optimal way, but I just want to have some traffic when we deploy and roll out the new version. So this is the current production, and our fat jar should be created. Yeah, it is. Yes, it is. Now we just build Docker image. We'll call it Pac-Man collectibles. So normal. Who uses Docker in production? Oh, not as many people as I thought. So we are building this image, and then Kubernetes deployment, I will show you in a bit, will just get this image and deploy it. So version 1, Docker build -t. So we are building, using this fat jar, we are copying this into this image, and this image will be our deployment module. And yeah. And then if this image is built and pushed, we can use this kind of deployment file, deployment definition. So we will, Kubernetes uses YAML or JSON, but we'll use YAML. We can just specify what kind of deployment do we need. So deployment is the name of the deployment and the specification here of the containers that we want this deployment to be taken care of. So this deployment, what it will do, it will just get this image and keep it running. If it fails, it will restart it, and so on and so forth. that's how it works. So this is all we need in order to have this container running inside this Kubernetes cluster. But we also need a second deployment file, the deployment manifest file, the service. Service is exposing the functionality. As you can see, it's exposing the functionality on port 8080, so that other services can use that. So that's all. We should have this Docker image built, and now we are just applying kubectl. Do you guys see that font? Just tell me. Bigger. Now? Yes? OK, cool. So kubectl. We are just applying this YAML file, kubectl -f Pac-Man collectibles YAML. Right? So the one that I shown you with service and deployment, we are just applying it to our current cluster. kubectl apply. I said apply, I didn't write apply. kubectl apply to this cluster, service collectibles unchanged, and because it was already there, but the deployment collectibles has been created. And now we should be able to see, when we refresh, the new deployment over here. So there is this Kubernetes, collectibles deployment version 1. Okay, so deployment should be taking care of the containers, and as you can see, there is a container running with some logs, right? That is running on port 8080. So that's kind of how we deployed something on production, because this is a production cluster. So now we have this collectibles service on production, and we should be able to just play with this new dots, right? Let's see. No, we don't, because we just pushed a new version, but this version is not used. And now is the hard part, right? We have this one on production. It's not used by backend on frontend, but we need somehow to roll it out. So what we did, just to wrap up this very, very quick session of live coding this new service, was we created some code by using very, very fast HTTP server tests without running HTTP server. So this is kind of power that we have when we are using function as first-class citizens. We didn't have any state in our HTTP routes. It was very, very fast, and it is stable because it doesn't do any real side effects. And besides the one that we created, this connecting the dots test, right? And then we deployed by using this Docker image and then deploying it using deployment for Kubernetes. We specified the YAML and then deployed it to Kubernetes. Again, one slide of code in order to do the whole full happy path of our web microservice, right? So nothing more. If you want to have some corner cases, you can have a small service, a small test like that in order to cover that. But as long as the integration between this state concern and HTTP concern is taken into account, that is all we really need. And the deployment, just deployed it to Kubernetes. So now we have 3 services: backend, version 1 production, collectibles version 1 production, and front-end version 1 production. But as we saw, we still don't have this functionality of eating the dots, the thing that really makes Pac-Man goes around and very, very popular. So our current architecture looks like that. So we have this player which connects to front-end, and then back-end serves this old implementation, right? So the grid and just moving around in this grid without the integration with collectibles. And we have this collectibles version 1, which is not really used. We can, of course, use Postman to test it or do some automated tests using real HTTP, but it's still not there. What we want to do is we want to push it on production, right? So the traditional approach, one of the traditional approach, very, very popular one, because if it works, the Big Bang, who did Big Bang in their career? Like real Big Bang, just push it on production and switch everything, and it looks what happens. Not many as you, as I thought. Maybe some of you are just scared of admitting that. But let's be honest, this is very, very nice feature, because if it works, then we saved a lot of time, right? If it works. So this is a traditional approach. The second one is to create another cluster besides, and then test everything, and then push it to production like a big bang, because we tested on production-like cluster. So I treat those two like the same one. So player creates a request to the front end, and now this is a version 2, so it uses collectibles. What if we are able to somehow get the benefits of those two approaches, like the safe deployment and the big bang one, so without using any clusters on the side? So we use this production cluster. For example, in my company, we have a cluster which runs like 150 services, so it's not feasible to run them on our local machine. So we then need to somehow make sure that the new services are OK to run on production without running the copy of the cluster. So we want something like that. We want a player to still be able to play with the current version, not very exciting, but current version of the Pac-Man game. And on the side, in the same cluster, imagine there are like 60 more services, like stores, leaderboards, things like that. We want to still reuse them and only change like 2 components, the front end and the back end, to check whether those new versions of front end and back end, which are integrated with collectibles, work fine on production. So this is something that we want to achieve. And this is achieved using something called per-request routing. So we are able to route to different services based on the request we are creating. So we can create a user on the site. It can be automated. We will be using that manually, but you can imagine that this is just an automated approach. Not very fast, as is in the code in Scala I shown before, but still automated on production, and that checks the functionalities, different functionalities before the deployment, right? So we want to have something like that. Automated player over here creates a request that is routed only to those 2 backend and frontend cherry-picked version 2s, which support these collectibles. So this is what we want to achieve. And we'll be using service meshes, service sidecars. Those are very, very similar things. I will try to show you the difference so that you are aware of what those definitions really are. So right now, what we have on production is something like that. Collectibles pod has this one container which we created, the Docker image, which was run as the Docker container, Pac-Man collectibles version 1. And this container is responsible for doing all those requests and accepting all those requests from the outside world, right? So in this approach, we will need to do, like, if you want metrics, Prometheus metrics, you need to create them inside the service. If you want Zipkin to trace all those things, you need to create that inside your service in order to have those kinds of things. So this is accidental complexity, right? All those things, that's very, very small service, very, very small service, and we need to push all those things inside in order to have some kind of observability, right? And that's not very, very, very nice. We don't want to do that, and usually many people don't do that. What about HTTPS, right? Who implemented certificates like key stores, things like that, in the application itself? Come on. Nobody. So everybody's using HTTP. But HTTPS, we'd like to have HTTPS, but we don't really want to generate certificates and key stores and pass it around. We don't want to do that. And that's why service sidecar pattern has emerged. So this is pretty new thing. It's like 2 years old, the concept. So it's in the very, very early stages. And Linkerd is one of the examples. I will show you more examples at the end of the presentation. So Sidecar is another container, which is deployed alongside our normal container. And it is responsible for doing everything. Everything. Every HTTP request needs to go through this Sidecar. And what it does, it gives us many different things, like service discovery and also the telemetry and things like that. So it is responsible for doing all outside requests and, of course, inside as well. So this is Sidecar. Sidecar because every application has our container and this Sidecar container. And service mesh, so this is service Sidecar. And service mesh is something, if we have limited resources, we don't want to have like twice as many containers in our cluster. We can use something like service mesh. So fewer proxies containers deployed, like per host, for example, but still all the traffic is routed through those instances, and they are synchronized together in order to create this kind of mesh, right? Inside which all of our applications are run. So this is service mesh and service sidecar. And if we have something like that, we can do this per request routing thing, because Linkerd is now, or our service mesh is now responsible for doing all those routing things. So for example, our player still plays production Pac-Man without any dots, but our test player is able to somehow make sure that all the requests to the same addresses as before, so no new addresses, no new environments, the same production address, but it will use a different cherry-picked versions of our services. So now we are able to test on production, but only the cherry-picked versions, and see how those guys work together without really affecting anybody, so in isolation. So let's try to do that. And again, what we have here is we have three deployments, right? Backend, collectibles, and frontend. And we need to have those new versions of backend and frontend which are using collectibles. So we will just deploy them. I will show you just the backend one. It looks very, very similar. So we need to have a service that exposes things, and we need to have a deployment in order to deploy the new version of Pac-Man backend, version 2. Version 2 uses this new service we have created. So we are just applying those two YAMLs. Pac-Man, first we deployed backend test, and then we'll deploy front-end test. Still, we just deployed front-end test and backend test. As you can see, they're already running inside our cluster. But still, if you go back to our Pac-Man, this is still a production application. So it still uses version 1 of backend and version 1 of frontend. But we have 3 more services that we now want to cherry pick inside our normal production application. So normal production application, the same address, I'm not changing anything. What I need to change here is just the header. So this is per request routing. And this is like an add-on for home to change the headers. And the header is called L5D, which is a numeronym of Linkerd, Linkerd DTAP, and the value is like that. So this looks like that. So if there is a request that goes to the Pac-Man Kubernetes namespace on HTTP to the front-end application, front-end service, then just what you do, you just whoa, no, don't do that. I will need to write it. So again, can you see that? Guys, in the end, in the back? No, not really. More? Okay. So we'll write that. If we have this request that's going to Kubernetes Pac-Man namespace HTTP backend, then we want to just replace that with Kubernetes, the same namespace, and HTTP backend test. Only for this particular request. So everything else stays the same. And the second thing we want to do is we want to have this Kubernetes Pac-Man HTTP frontend. So we will be cherry picking two things, frontend, and it needs to go to Pacman HTTP frontend test. So this is kind of what we did. We cherry picked two headers, and now I just enable that and refresh the browser. So I'm using the same functional, the same address, but now the request is passing the header around and just uses these new services on production. So if we have 60 of them, we just cherry-picked 2. The rest is the same. So now we are testing on production in isolation, and those dots are really generated by this thing we have just implemented in Scala and tested. And a good thing about that is that it can be HTTPS by default because this is service mesh, and this is what I want to show you right now. So isolated tests on production. What we did, we rolled out collectibles. By changing the routing header, Linkerd was able to pass around this override, this DTAB header, to all the services. So even if we have like service 60 levels deep down over here, and this is the one that we want to cherry pick for testing, this is still possible because Linkerd will just be able to pass it through with some additional things like like header forwarding. But this is the only thing that we really need to do in our services. The Linkerd will be able to replace those particular modules with the one that we want to test. So this is how it worked. DTABs is the functionality in Kubernetes, in Linkerd, sorry. And this is just one approach of per request routing. So this is kind of approach that Linkerd has taken. Linkerd 1, because there is a new, in September, released Linkerd 2, which I will talk in a bit. So DTABs generally are the thing that routes all the traffic inside this service mesh. And if we can cherry pick using this header, we can really cherry pick anything we want based on the request we are creating. And this is thanks to Linkerd being the proxy between all of our services. And as I mentioned before, very briefly, we get things for free, and for free, really for free, because we are inside our service, we are doing HTTP and just connecting with this local host. And everything is done for us. For service discovery, circuit breaking, like the retry budgets, everything like that, everything is done for us. We can configure it on this control plane level, on this Linkerd level, for all of our services. Of course, there can be exceptions, but still configured in one place. We can keep it in Git in one place. So this is for all our services. If you have hundreds of them, then probably it's a good thing, right? You have this kind of configuration in one place. Security, HTTPS termination or TLS termination can be done on the level of service mesh. So you still can connect with your application like on HTTPS, but inside your application, you can just get HTTP because Linkerd is transforming this HTTPS to HTTP inside your isolated container in pod. And of course, telemetry like Prometheus, Zipkin, as I said, you get that for free. Incoming HTTP requests, all these things like how much time did the request take, and tracing, the real tracing. So telemetry, observability, you get that for free. And that the one that I created, the service, is enough for you to really push on production and have all those things. And Linkerd is just one example. So we have service meshes, service sidecars, and proxies. This is a still evolving kind of branch. And Kubernetes and Istio are very, very close together. There are many companies behind Istio right now. So all those things, per request routing, you can do in Istio. You do it in more Kubernetes native way because you are just deploying YAMLs in order to change the routing of your services. But still, the functionalities are the same, and the main concept is the same. Linkerd 2.0 written in Rust, so the Linkerd 1 is written in Scala. Linkerd 2 is written very, very lightweight in Rust and Go. Different approach. And Envoy is a proxy, right? So this is a little proxy that is used, for example, by Istio. But if you want to use something like that, you can. Linkerd 1 is the most battle tested. So it's like 2 years old, and many companies has already used that in production. So this is probably what you should use if you want to use that on production. But if you want to just play around, Istio is probably the way to go next. So conclusion, what we really want from our tests is the certainty, right? Certainty that it will work. We don't really care about units or components or integration. We want them to be fast. We want them to document things. We want them to be stable. So this is what I really want to achieve. And this kind of pyramid, which is like 20 years old or so, is not really conveying this information, right? The pyramid says that we should have like many unit tests, right? Because they are fast. No, so this is kind of mixing two things together. So what I'm suggesting is we just have this two-layer pyramid. We have many tests, as many as we can, to test the real functionality using things like functional programming, but probably you are able to do that also in the imperative world. But think about that, right? Separate concerns from each other, and don't use like big integration tests and have clusters on the side. Real tests should be on production because production is the most you can get, is the closest you can get to production, right? So real tests on production, but in isolation. So routing test traffic is I think it's a great idea, and we should be able to come up with something better based on that. But this is the current thing we have. So routing on production using per request load balancing in isolation. No mocking. So we don't really mock any databases. We don't mock things inside our tests. Mocking like the objects which have 5 functions. There are many complex things that can go south. And no HTTP servers. So we are just testing HTTP layers. Why do we need to test the implementation of the library? And abstracting over data using function parameters to externalize the assumptions about our code. So this is a new testing pyramid. And this boundary between light blue and dark blue is something like airplane mode boundary, right? So those tests on the bottom, you should be able to run in this airplane when you are going, even for HTTP. And the top level is just for your production, so it should probably be connected to internet. And as you probably knew, where I was heading, the bottom for me is functions, and the top for now is service meshes. So we are using service meshes in order to do those real tests on production. So next steps for you. You can use Katacoda. So this is very nice thing because you can have you can play around with Kubernetes in Istio or in Linkerd using this kind of web interface. So it's what this project does. It just sets up a new Kubernetes for you inside their virtual machine, and gives you access to terminal when you can play around and give the comments. And of course, they are telling you what to do, and you are learning. You can really deploy, for example, Prometheus with Grafana and all those things for the very simple web service, and see how service mesh works in this kind of scenario. So there are many scenarios. Linkerd and Istio are the ones to go, right? And we are doing this kind of approach in the reality games. We are developing 3 new games, and this is exactly what we've been doing. So there are many problems with that, but we are learning. This is a new thing, and lots of mistakes still needs to be done. As I said before, Linkerd 1 is probably a way to go for production right now. We played around with Istio, and it's not so stable. But still, there are problems even with Linkerd. So as I said, pretty new. So thank you very much for your attention. My name is Michał, and this is my Twitter and my blog post, my blog site. And thank you very much for your attention. And what questions do you have? What questions do you have? Anything goes. One over there. Sorry, can you wait for the microphone?
Did you encounter such a situation when your new module affects somehow the production data? And
of course, yeah, we've had situations like that. Kafka topics, for example. So if the new service, we can cherry pick a new service, and this will consume things from this Kafka topic, which is production, and it will not be consumed by this production service. So it says in isolation, but it's not for free, right? So you need to think about what isolation means for you. So probably you will need to create topics for your test, just for your test modules in order to do that. Or consumer groups, whatever.
Yeah, okay.
Something, right? But you need to think about that. Okay?
Okay, thanks.
No problem. Any more questions? No questions. Okay, thank you very much. Enjoy the rest of the conference. Thank you.